I am Anil Kumar. Welcome to my series on exponential functions. We are actually taking test questions to understand the concepts. In this video, we'll actually try to understand how do we sketch a transformed exponential function. So the example here is question number 5. Graph y equals to minus 2, half to the power of minus x plus 3 plus 2. You need to sketch this graph. Now, whenever you're given a function in this form, the x coefficient should always be 1. So we need to factor this to really understand the correct transformation. So let's rewrite this particular equation as y equals to minus 2. And here the base function is half for us. And this is minus. If I do that, then I get x minus 3 in the brackets plus 2. Now this particular transformation actually tells us how the graph will be transformed from the base function to the given transformed function. So the parent function will consider the function f of x as equal to half to the power of x, right? And this transformed function y is as given to us, right? So from this base function, we are transforming to this particular function. Now, if you look at it, then what is the transformation of each point? As you can see, the x values, they get reflected on the y-axis, and each x value moves 3 units to the right. So a point which is xy on the base function half to the power of x will now get transformed, and the x values will get multiplied with negative, and then you'll add 3 to it, correct? So that is a transformation of image point from the original point. The y value will get multiplied by minus 2, and then you have to add 2, right? That's the first thing. Now to sketch a function, you should take 5 critical points to sketch, right? So you should consider at least 5. Right. So what could be those 5 things to consider? So let's make a table here and then see those 5 things. So we'll consider what happens in the original function and what is in our transform function y equals to minus 2 half to the power of minus x minus 3 plus 2. Right. Let me also sketch the original function half to the power of x on this graph itself, and then we'll take up the points, and we'll also discuss the transformation, both which we could do in steps using the graph and also using the table of values. So that should help all of you to understand complete concept. So let us say we have f of x equals to half to the power of x. In that case, it really means that it is exponential decay. At x equals to 0, always you'll have 1. If I write x equals to minus 1, we get 2, right? So the value increases on this side. Here, if I take x as 1, I get half. And as we go further, the values decreases. And you see this as an horizontal asymptote, correct? Now here, it will be, if I take this as 2, we'll have minus 2, it'll be 4, right? So it'll be 2 and 2, 4. So that will be your point. So the original graph will be kind of like this. So that is the exponential decay. And from here, we understand a couple of things. One is that when x is approaching negative infinity, y is also approaching infinity, right? Which is positive infinity in this case. Then let's consider these 3 points. When the x value is minus 1, y value is 2. When x value is 0, y is 1. And when x is 1, y value is 2. And then when x approaches positive infinity, y approaches 0 from the positive side. Is that clear to you? It is still positive, correct? Now if you look into the transformations, as far as this transformation of image points are concerned, we can substitute the values here and then find what happens. So minus infinity, if I do negative of that, then definitely negative makes it positive, and anything added to infinity will be infinitely large. On this side also, when I substitute infinity and we have to multiply by negative, that means it goes to negative infinity, right? So that really means when we are approaching positive infinity for the transformed graph, it goes towards negative infinity, correct? That is what it is reflecting at, kind of going downwards, right? Next point, minus 1. If I substitute minus 1, minus 1 minus 1 becomes plus 1, so we get 4. The y value get multiplied, minus 2 times 2 becomes minus 4 plus 2 is minus 2. So likewise, we can get all the points. For 0, 1, the image will be 3, and when I write 1 here, we get 0. For 1 and 2, if I write 1 here, then 3 take away 1 will be 2, and the y value will be minus 2. When infinitely large value is placed for the x, it becomes negatively infinitely large, and when I place 0 here, we get 2. Correct? So now it is important to understand that this one here is a reflection on the, so these are the set of points which should lie on a transformed point, right? So we could always sketch these points and get our graph. That is one thing. Now let us also look into the stepwise transformation. So let's do steps. Now this particular parameter here, the negative, shows a reflection on the x-axis. So basically these points get reflected, right? So this point comes here, that goes there, and this goes 2 units, right? And then we have that point which goes to this place, approaching from negative. So we get a function which could be graphed like this. Correct? Now this graph is for minus half, right? So minus outside to the power of x. The next step here was to multiply this by 2, right? So that means they all get vertically stretched, right? So they all get vertically stretched. So the point at 2 comes at 4, right? So this comes to 1, and therefore we have a graph which is kind of like this. So that takes care of this too. The negative here means that your graph is going to be reflected on the y-axis, correct? So it gets reflected, so this point will come on this side. The whole thing kind of changes. The points here will be invariant points. That point goes there. So what we get here is kind of like this. So that takes care of the reflection. Correct? So I'm just drawing each and every step here. And now we have a translation. We have to move 3 units to the right and 2 up. We have to move 3 units to the right and 2 up. So what we got here were these critical points which we are trying to monitor, right? So this got reflected here, it remained, and the point here was this point. Now these 3 points which we are considering will now be translated 3 units right and 2 up. So if I move this 3 units right, 1, 2, 3, and 2 units up, that is the point which I get. 3 units right to this point, 1, 2, 3, and 2 units up. 3 units right, 1, 2, 3, and 2 units up. Do you see that? So we get this set of points, and these points actually match with our numbers probably. Let's check. So here we have 4 minus 2. So that is the point 4 minus 2, correct? Let me circle this. Then we have 3, 0. 3, 0. And then we have 2. So at 2, let's calculate this value once again. So if I write at 1 it was, sorry, this is wrong value. At 1 it was half. Right. So at 1 it was half. So when I multiply with minus 2, so it becomes minus 1 and we get plus 1. Correct? So this should have been plus 1. Right. Yeah, it makes sense. So at 1 it was half. So here it is 2, 1. So we found our error also. 2, 1 is this point. Do you see that? So we do get the same points as we had calculated. Correct? So these are the image points. Original. So this is an alternate way of sketching, which is sometimes a better way of sketching also. Now look here. When I say this is my, when x approaches the infinitely large value, then y approaches minus infinity. That means kind of going downwards, right? Towards negative infinity. And the other one says when you are approaching minus infinity, then the y value approaches 2. That means 2 is your horizontal asymptote, right? So now the horizontal asymptote is at 2. Earlier, the horizontal asymptote was at 0, right? Do you get the idea, right? So that was the horizontal asymptote. So let me sketch the horizontal asymptote here. So that is our horizontal asymptote, correct? Now with that, let's connect all these points and sketch the final function. So what we get here is a function which will look like this. So I'm focusing on the 3 points which we calculated and the end behavior. Do you see that? So that is how we get our final graph, and that is the graph of our function y equals to minus 2 half to the power of minus x plus 3 plus 2. Is that clear to you? So what you really see here, that even if you do the right calculation for the image points, you could easily get the graph. Sometimes in the question, you have to show all the transformations as we did in different colors. That also works, right? So I hope the whole concept is absolutely clear. Feel free to write your comment, share your views. One more thing could be here to write domain and range, right? So let's include that also. So as far as the transform function is concerned, you see in the transform function, the domain is all real numbers, right? As far as the range is concerned, what we have is that y belongs to real numbers. However, the value of y is always less than 2. Less than 2, correct? As shown here. So that becomes your domain and range. And of course, you can find other parameters like x and y intercepts and so many other things. So our focus is basically in this video on how to sketch. And I hope this point of how to sketch an exponential function with this example is absolutely clear. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.